Okay, today you guys are going to be learning about how to solve one-step equations. Alright, so in order to solve one-step equations, what we're trying to do is isolate the variable. So in this first example, we see that the variable is x. I am trying to isolate it by getting rid of the positive 5 that is next to it. Okay, I see that I'm adding 5 to the x value. So what I would want to do to solve for x or get it by itself is to actually do the opposite operation. So I see I have addition there. The opposite operation would be subtracting 5. Now, I would subtract 5, but in order to keep this equation balanced, I need to do the same thing to both sides of the equation. I can almost think that there's an imaginary line going through the middle of the equal sign that is splitting the equation into two sides, a left side and a right side. So I want to make sure that I do the same thing to the right side of the equation to keep it balanced. So I would also subtract 5 from the right side. Alright, now for my answer, I now get that I have x by itself because 5 minus 5 makes 0, and I have that x equals what I would get for the result of negative 12 minus 5. Now, if I think about putting those numbers on a t-table, they're on the same side, they're the same kind of numbers. I would actually add them, and I would just get a bunch of negatives, so I would get negative 17 for my answer. Okay, so for example 2, I'm going to take a look at this problem. If I split my equation into a left side and a right side, drawing an imaginary line through the equal sign, I see that on the left side next to the variable t, I am subtracting 7. So the opposite operation of subtraction would be addition, so I would be adding 7 to both sides to solve it. 7 and negative 7 make 0, so on the left side I would be left with t, and on the right side I would get 22. Okay, in this equation I notice right away that it's written slightly differently than the last couple. I notice that if I were to draw that imaginary line, I see that the equation here has a variable on the right side, and in the previous problems it was on the left side. So one thing I can do is I can rewrite my equation in a more mathematically preferred way so that the variable is on the left side of the equal sign. So what I'm going to do is go ahead and rewrite this before I start. So I'm going to rewrite t plus 4 equals negative 5. All I've done is I've moved the t plus 4 over to the left side, and I moved the negative 5 over to the right side. I'm allowed to do that. Okay, so now that I have rewritten it in a more mathematically preferred way, I'm going to go ahead and draw my imaginary line, and I'm going to identify what's happening next to the variable t. I see that I'm adding 4, so the opposite of adding 4 would be subtracting 4. So I'm going to go ahead and subtract 4 from both sides, and I would get t is equal to negative 9. Okay, in this next one of the things I notice in this next one is I see that I have an equation where it looks a little bit different than the previous ones. The reason being is the variable isn't written first. It's written second. And so I notice that this order that it's written in isn't really mathematically preferred. To make it easier for you guys, what I would tell you to do is just rewrite this equation in a more mathematically preferred way. So what you can do is you can take this whole positive b and you can move it to the front of the equation. So I'm going to go ahead and have positive b. I still have a negative or minus 11, and next I would then have equals 17. Now that I have gone ahead and rewritten this in a more mathematically preferred way, I can go ahead and solve it. So now I can identify what's happening next to the b term. I see that I have negative or minus 11. Well, the opposite of subtracting 11 would be to add 11, so I'm going to go ahead and add 11 to both sides. When I add 11 to both sides, I'm going to see what I get. And so for my final answer, I get here B equals 28. Okay, in this next example, I notice that I don't have any adding or subtracting in this example at all. So what do I have here? If I look at this side with the variable, what is actually happening between 2 and the variable? Well, if I think about what's actually happening, there's really it's not written, but there's a dot there that implies multiplication. So what I really have on that side is 2 times x. Okay. Now, in order to solve this equation, I'm going to draw my imaginary line so that I can keep it balanced and do the same thing to both sides. And I'm going to do the opposite operation of multiplication. So the opposite operation of multiplication is division. So I'm going to divide both sides by 2. I'm going to draw a division bar and divide both sides by 2. Now, when I divide both sides by 2, 2 divided by 2 makes 1, and 1 times x just leaves me with x. On the other side, 82 divided by 2 gives me 41. That would be the answer. Now, if I'm not sure if I do any problem with solving equations right, what I can do is I can check. I can check my answer. What I can do is I can take 41 and I can plug it back in to the original equation and see if it works. So, does 2 times 41 make 82? Well, yes. 2 times 41 is 82, and 82 makes 82. So yes, that checks out. Okay. So if you're ever concerned or questioning whether or not you've solved it correctly, just take your answer and substitute the value back in the place of the variable in the original equation, and then you would work it out and see if both sides end up being balanced. Okay, so let's look at this one. I notice right away that the variable is on the right side instead of the left side. What I'm going to do is I'm going to rewrite my equation, reordering it. So, all I've done is reorder the equation. Now I'm going to go ahead and solve it by doing the same thing on both sides. So I see that 4 is multiplying by c. The opposite would be dividing. And so for our answer, we would get c equals, now I'm going to be careful here, a negative divided by a positive makes a negative. All right, in this problem here, what I notice is that I don't have multiplication anymore. The operation that I have, this bar right here, that means division, right? That's a fraction bar, meaning division. So the opposite operation of division would then be multiplication. So in order to solve this equation, doing the same thing to both sides, what I'm going to do is I'm going to multiply both sides by 4. Now, when I do that, what I end up getting is on this side over here, I get 4 over 4. Well, if I have 4 in the numerator and 4 in the denominator, that means I have 4 divided by 4, and so that means I have 1. So you can think of it as reducing on the diagonal or dividing, but these two 4s basically make 1, right? 4 divided by 4 is 1. So what I'm left with on the left side is a, and on the right side now I have negative 20 times 4, and negative times a positive is a negative 80. All right, for this last example here, what I notice is that I have an equation with division, but it's not really written in a mathematically preferred way. So I'm just going to go ahead and I'm going to change the order, rewriting the equation with the variable on the left side. Now, after I've done that, I'm going to go ahead and identify what operation is happening here. So right here, this bar, this is my division bar. So the opposite of dividing would be multiplying. So I'm going to go ahead and multiply both sides of the equation by 2. The reason I choose 2 is because 2 is what's in the denominator there. So 2 divided by 2, that makes 1. Okay, so 1 times r, or r divided by 1, is just r. And now negative 14 times 2 gives me negative 28 for my answer. Remember, if you're not sure if you did it correctly, take what you get and substitute the value back into the equation. I'm going to check. Does negative 14 end up equaling negative 28 divided by 2? Well, if I simplify that, negative 14 equals 28 divided by 2, negative divided by a positive would give me a negative. So yes, it checks out. It does end up working. Alright, in this very last example, I notice that I have a variable on the left side of the equation, but it kind of looks different than the other ones I've done so far with division. The reason why it looks different is I notice right away that the variable is in the denominator. Okay. I don't really care to work with the equation like this. Okay. And so one thing that I can do is I can rewrite this equation so that the variable is in the numerator. Now, if I'm going to do that, if I want to use the reciprocal of the left side by flipping that over and putting r in the numerator, I'm also going to have to use the reciprocal of the right side. Right now, on the right side, I just have negative 11. It's just like an integer. It's not written as a fraction. So let's write negative 11 as a fraction by putting 1 in the denominator. Now what I can do is rewrite both sides of the equation by using the reciprocal on both sides. So now that I've flipped over both sides, or used the reciprocal of both sides, now I can go ahead and do the opposite operation. I see that the variable is being divided by 5. The opposite of dividing by 5 would be multiplying by 5. So if I'm going to multiply by 5 on the left side, I'm also going to multiply by 5 on the right side. Now, what I'm left with here is r on the left side, but on the right side, I'm going to have to multiply 5 by 1 over negative 11. So remember, we just learned about multiplying fractions. When you multiply a whole number, just put a 1 in the denominator, and then you can do top times top, bottom times bottom. So 5 times 1 gives me 5 in the numerator, and 1 times negative 11 gives me negative 11 in the denominator. Now I notice that this isn't really the mathematically preferred way to write the fraction, so I'm going to go ahead and write my answer in the mathematically preferred way. R is equal to negative 5/11. This would be how I'd write my final answer.